BGP runs on top of 179 port number TCP. In case if you are establishing the BGP, okay, if you have any firewall in between, or if you have applied any access list, all those, okay, then you should allow the port number 179. Okay, where this kind of issues will come when you have the internet router or perimeter internet facing a router. So people will configure access list to avoid ICMP, all those things. Okay, only outbound traffic they will allow it. Okay, in such case, we have to allow TCP 179 to form a neighborship between your router to service provider router. Otherwise, your BGP only self will not turn it on. And then BGP is more reliable protocol. Why more reliable? Since it's used TCP. When TCP comes, okay, it will be the more reliable than other. But one thing is slowest routing protocol. Because of a convergence of routing table. It will take 180 seconds for getting update all those things. That's why this is slowest routing protocol. BGP is a slowest routing protocol. Yeah, what has happened? It advertises, learns, and chooses the best path inside the global internet. Whenever the BGP runs, it will advertise, it will learn the routes, and then it will choose the best path which is available in the internet. Internet in the sense, okay, whichever is available over the your channel. Okay. The ESPs typically use BGP to exchange routing information between themselves. So whenever the service provider they're running the BGP, okay, they'll use the BGP as a routing protocol to exchange the route between them. Okay, this will be like a stable routing protocol. Okay, as well as okay, it's the slowest routing protocol because of its convergence. It will look all the parameters of this BGP matrix, then it will derive the best path. Okay, BGP has very robust algorithm for choosing a best path. It is a very robust also. Which algorithm it uses? BGP technically, if you see, it is a distance vector protocol, but most called as a path vector protocol. Technically, it is a distance vector protocol only, algorithm only, but if we'll call as a path vector. The distance vector algorithm, okay, it might be using studied in the mathematics. Okay, based on the vector, it will choose the best path. This is path vector. So in theory, okay, we should understand how this algorithm works. See, the BGP have some tuning. Otherwise, okay, it will work as a RIP. Even RIP also distance vector protocol only. Okay, this is since having some tuning, that's why it works as a very effective way, robust way. Okay, it is a algorithm by using the distance vector algorithm. It is designed in the different way. So that's why it is work as a very best algorithm out of the all the known algorithms like OSPF, all those things. Okay, the BGP is the best algorithm, we can say, when it's comes to the exterior gateway routing protocol. BGP use the best path selection based on the multiple criteria because it has to complete the complete topology. It has to understand different attributes. Okay, it will be aligned with the multiple algorithms. Then it will choose the best path. Okay, all those attributes, all those things we'll be discussing in upcoming sessions, very in detail. Now, let us see the similarities between iBGP and BGP and IGP, Interior Gateway Protocol. Similarities, let us see. BGP needs to form a neighborship. It's to form a neighborship like iBGP, IGP. Even RIP also will build a neighborship. OSPF also will build a neighborship. AGRP will neighborship. Similar way, BGP also needs neighborship like a other routing protocol, other interior gateway routing protocol. BGP needs to form neighborship like other IGPs. BGP also advertise the prefix like other interior gateway routing protocol. Needs to advertise prefixes. Prefixes means what? Our subnets, IPs, our networks. Prefixes just like IGP. Where BGP will advertise the prefixes next hop. How about other routing protocol? Those protocols also will advertise prefixes to next hop. First it will advertise to next hop. Then only it will forward the other hops. That next hop it will keep on getting forward. Next hops for those prefixes. See, what is major difference if you see in the BGP, uh, IBGP, IGP or in IGP, if you see the OSPF or eAGRP RIP, it will form the neighborship with connected networks. Like neighbor also will be having the neighbor with the same network. For example, let me show you. I have one router. Here I have one router. Okay, I'm using 192.168.1.0/24. I have assigned here .1 IP, here .2 IP. Here I can build a OSPF. I can build a OSPF here. I can build BGP also. Here I can build a RIP, eAGRP. Okay, this is the normal scenario. If scenario comes as router, for example, router. For example, this router acting as a transit router. Okay, here I'm using a network as 192.168.1.0, here .1, here .2. Here I'm using as here 192.168.2.0, here .2, here .3. Okay. Now I want to establish neighborship between this router to this router directly without, here I'm using some static route or something. Okay, I want to establish here to here neighborship. Okay, with this, my here peer IP will be 192.168.1.1. Here my peer IP is 192.168.2.3. If I want to establish neighborship between these two, OSPF, no, we cannot do. BGP, no, we cannot. Sorry, BGP we can. BGP only it's possible. RIP, no. OSPF, no. eAGRP, no. Only this is the case is possible only in BGP. Neighbor IP address may not on the common subnet for BGP, but in RIP, eAGRP, OSPF, we need to be in common neighbor IP. Here, if you say this, take this scenario, okay, the neighbor is not a common subnet. Neighbor is not a common subnet, even though we can build a eAGR, BGP. But eAGRP is not possible, OSPF also not possible. It's not similarities. If you have the similarities, okay, we can say these are similarity, differences. Okay, till this point, it is similarities. Okay, from this point, it's a differences. If you see the routing protocol, that is a difference. Okay, what is the other difference we see? IGPs do not use TCP, whereas BGP uses TCP port 179 between neighbors. Okay. This is what similarities and differences. Now, let us discuss overview of overview of iBGP and eBGP. Under the BGP, we have two flavors. One is iBGP, another one is eBGP. Let us discuss about there are two types of neighbors in BGP. One is internal BGP, another one is external BGP. Internal BGP will call as a iBGP, external BGP will call as a eBGP. If within the same AS, same number AS number, if it builds a BGP neighborship, then it will call as a iBGP. Same AS BGP neighborship is iBGP. Case iBGP. If different AS BGP neighborship is eBGP. See, what is the loop avoidance? If you see iBGP and eBGP, it will look the AS path. When it looks on AS path, then it will not install those routes into the routing table. If you see the different, it maintains the different attributes. Already we discussed. Okay, it maintains the different attributes for the BGP. Okay, to select the best path. Those attributes and all we will discuss in upcoming classes. Okay, we will look iBGP loop avoidance also. Okay, when iBGP, whenever it is advertising the routes, okay, it will not receive the same routes from that iBGP. That we'll see in the lab while doing the lab in detail how that works. If other routing protocol, if you see, it uses the multicast. Okay, BGP use unicast. What is a unicast multicast? Multicast means one to many. Unicast means one to one. Why? Because I know my neighbor. Which neighbor I'm going to establish neighborship. This is a unicast fact. If you see the other routing protocol, okay, BGP, OSPF and all, it uses the multicast. Okay, while discussing about those routing protocol, We will do the packet capture and we will discuss. Okay, we are saying AS number, AS number. What does the AS number mean? AS means autonomous, autonomous, autonomous system number. It is the number which while configuring BGP, we'll use it. Let me open it. This number. There are two AS numbers like IP address, private and public. What is that? Private and public. There are public and private AS number. So the AS number 0 is reserved. We cannot use it. Okay, it will starts from 1 to 6 5 5 3 5. We can use it. Public AS number. If you see the public AS number, 1264495. That is a public AS number where all internet service providers will be used those AS numbers. Let me go show you one more thing as well as AS lookup. If you see AS and lookup, you see 4775. Is the service provider. What is it? Tata 4779 or 775. Like Tata something. Okay, like each and every AS number. Okay, it has to register in INR. Otherwise, this private AS number, public AS numbers has to registered in INR. We have to procure from them. Otherwise, we cannot advertise in the internet. Tata AS number, if you see all our service provider routers, we will be configuring with 4755. If you see the 4755, we will conclude that is a Tata AS number. If you see any of the Tata links wherever it is there, okay, that AS number, the neighbor IP will be configured with the 4755. Okay, this AS number has been procured by Tata. So for example, if I click AS number 1, let me enter. Who has used? Level 3. Okay, AS number 2, who has procured? Okay, University of Delaware. Like that. Okay, if you see the AS number 64495. Okay, no one is using this. 90. Montishibishi, something name is there. Okay, their CADR range also is there. Okay, 4755. If I enter, they have AS number. They'll be having that CDR value also. They what IP they have procured from Apnic, Apnic or IRA. I can say INA. Okay, if India it comes under, it will be Apnic. Okay, the AS number. There are two types, private and public. Okay, if you see the private AS number 64512 65553. You see the public AS number 126445. See the people mostly while configuring the router, they'll be even though they'll use the public AS number also to configure the router. See while configuring the using the public AS number in the private network, you're not going to make any harm. Okay, but when we are going to talk to the service provider, okay, that time it will make it complex. Always use the private AS number while configuring internal MPLS router, all those things. Within your organization, if you are using it, okay, commonly you reside for this location. Within this private range, you can use it anything. Or if you want to use the private public AS number also, you can use it. Okay, but when you want to go to or going to advertise with public network, that will not going to work. Okay, this what understanding about public AS and private AS. Should match some following criteria to become a neighbor. BG, BGP neighbor. What are those criteria? Let us discuss. See, when router want to become a neighborship, opposite router and local router configured properly with ASN number, autonomous system number. Otherwise, the BGP neighborship will not get formed. The following are requirements that must be met for the routers to become neighbors. First is a local router ASN autonomous system number and router BGP. That ASN command will give, right? Router BGP. It must match the neighboring route. For example, while configuring the BGP between two routers, if I'm configuring AS number as 1 here, AS number as 2 here. Here I have to give a neighbor IP AS number 2. Here neighbor IP AS number 1. It should get match. Exactly. Otherwise, EAG BGP will not get established. ASN next. But remote is listen command. We should do configure this. Otherwise, it will not get established the connection. See, second thing, the peer must be reachable via any way. Okay, the route might be our IGP route or any way. Okay, the peer IP peer must be reachable. Otherwise, BGP will not get established. If any authentication you have configured, then authentication has to configure. Configure if configured MD5 authentication, then it should be configured at both the end. And most of the things, people where they will get a problem. Let me show you. For example, router ID. Okay, if router I'm configuring here also router ID 1.1.1 I'm configuring 1.1.1. I'm configuring. Then BGP will not get established. BGP will not get established. Router ID should not be the same. Router ID should not be the same. The router ID should be different. Then only the BGP will get established. Not be the same. If it is the same, it will not get established. Each router should be enabled with port 179. Then only that communication will happen. Each router must complete a TCP connection, which is a 179 with BGP peer. See, if you use a different network, okay, you use the loopback to loopback. Okay, if you're using the loopback to loopback communication and all, we have to put as a while establishing the neighbor, we have to use as a BGP uh, update source command. Okay. We have to mention a source IP. Source IP address used to reach that peer must match peer BGP. Okay. The update source, all those things we'll see. Otherwise, what will happen by default? See, for example, let me clear it out. Here, one router is there. Here, one router is there. Okay, here I'm using a loopback 1.1.1.1. Here I'm using loopback 2.2.2. Okay, 1.1.1 to 2.2.2. I have enabled the routing over the static route or interior gateway protocol. I use some protocols. Both the IPs are reachable here to here. When I'm configuring the BGP, by default, it will take exit interface as a my source interface. It will take exit interface as a source interface for establishing. For example, here 192.168 1.0 is there. So whenever I'm configuring the neighbor 2.2.2, 192.168 1.1, it will try to communicate to 2.2.2. But here I might be configuring neighbor IP as a 1.1.1. So here misconfiguration will happen. BGP will not get established. So here I have to mention specifically update my source as a 1.1.1. Then only it will not take a exit interface as a source. It will use this particular IP as a source. Then it will establish the BGP. Most of the time, people will get miss this. We will demonstrate in our lab this. That's what BGP update source will use it. Okay, let us start the lab for today. Okay, in the lab, we will discuss few more things. We will do the basic configuration of BGP today. BGP. Let me add two routers. Add routers. It take few minutes to turn on. Meanwhile, we'll decide what we are doing. 22 from 68 to 2.0/24. Yes, dot one. Yes, I done. Now the C router came up. Yeah, it's booting. It take few minutes to come to boot stage. Meanwhile, let us prepare a basic configuration, interface configuration. Notepad, interface GI 0/0, no start, IP address 192.168.1.2.1, 255.255.255.0. Another router. These are the basic configuration.
Enable config T. Primary router configured as configured. Secondary router also. Now we have done the basic configuration primary and secondary router. Let us see 92 neighbor to neighbor reachability is there. Now let us do the BGP configuration. Configuration T router BGP AS number. For router 2, I am deciding AS number is a 2. Configure. Neighbor, okay, neighbor IP, remote AS. Remote AS is what? Only this two command is enough to configure basic BGP for the connector network. Let me go to the other router. Router BGP 1 AS number. One is AS number. Neighbor IP as a dot 2. Remote AS 2. Now, this two command is sufficient to establish BGP show IP BGP or summary or show IP BGP summary. Okay. Where VRF and all is there you have to give us all summary. Okay, if no VRF. Okay, if you show IP BGP summary, it will show you BGP status. No, BGP is up. Okay, only two command is enough. Let us do with loopback. Let me create a loopback 1 IP address 1.1.1.1 255.255.255.255. Now I have created one loopback in router 1. Show IP interface brief. 1.1.1.1 is a loopback. Let me create another loopback here. Interface loopback to IP address 2.2.2.2 255.255.255.255. Now let us create. Okay, what I will do before that, I want to show you guys something. Let me run the Wireshark between these two routers. Capture. Okay, let's do information. I'm going to run Wireshark now. Now Wireshark is running. What I'm going to do? Let me shut down the BGP and we re-establish.
Config. Okay. So I can shut down the interface. Just left here. Shut. No shut. Okay. Now we'll capture the traffic. What is happening? Now BGP will come once the interfaces comes up. Okay, let us wait. Here I want to show you guys BGP. See here. All of a sudden BGP message came here. If you see, it's used as the TCP, Transmission Control Protocol. Source is a random port. Destination is 179. 179. And then if you see the Internet Protocol IP header, okay, it will have the source address 192.168.2.2 and destination is 192.168.2.12.1. So the first offering happened from router 2. Okay, and then router 1 is responding for that. Again, here the three-way handshake is happening. If you see here, first it's sending the SYN packet, then SYN act. After that, open message came, and then for open message again there is acknowledgement. Okay, acknowledgement is for this packet. Okay, and then keep alive message and the notification message. Okay, BGP messages we will see in upcoming sessions. What kind of messages are there? Okay, there are 4 type of messages are there: open message, update message, keep alive message, notification message. All those messages we will see in upcoming sessions. Okay. Now we could able to see all those messages: keep alive, update, live, all those messages. Now I want to show guys source IP and destination IP. Now let us go to my router. What I am going to do, router 1, let me go. Remove my router. Will give no router BGP 1. Same, I'm going to remove my BGP. Similar I will do here. I'm removing BGP. Now I'm going to create one static route between my loopback to loopback. IP route 2.2.2.2. Sorry, this here 1.1. From 2 and 1.1.1.1 255 dot 255 dot. Give me a moment. For easier identification, okay, to avoid a confusion, first let us create a host name. Host name, this I'll call it as a Chennai. Router 2 host name is a Chennai. If you see here also, you can come to know router 2. Okay. What is this? First, we'll consider host name. It will be easy for understanding host name. This is a Mumbai. Mumbai is a router 1. Okay, router 2 is a Chennai. Router 2 as a Chennai. Router 2 as a now let me create a static route. IP route 1 dot 1 dot 1 dot 1 255 dot 255 dot 255 dot 255. Next stop is 192.168.12.1. Okay. Now let me create a one static route here. IP route 2.2.2.2 255 dot 255 dot 255 dot 255 192.168.12.2. Now we have created loopback to loopback option. Let me ping 1.1. From router 2. We are able to ping. Now we are going to establish BGP between loopback to loopback. Now let us configure a BGP here. Router BGP 1, enter, okay, neighbor 2.2.2.2, remote as configure local system as a, okay. The second router I'm configuring, okay, we have to, okay, neighbor IP is supposed to give, okay, let me reconfigure it. This is the second router I'm there, router BGP. Now let me go to the first router. Let us configure here. Router BGP 1, neighbor 2.2.2.2, remote access 2. Okay, let me go to the second router. Router BGP 2, neighbor 1.1.1.1, remote as 1. Now let's see what is happening in the packet capture. CDP, all those things, okay, this concerning. Okay, let us wait. BGP summary. Idle state. On the side, whether we have configured BGP summary. This both the side we have configured. Debug eBGP. Let me run the debug. What is the idle state? Why? See here, we could able to see 2.2.2 active open failed update source null is not available. Okay, because of update source is not available, it is getting failed. See here BGP, you're able to see. You're able to see. This is same. Let me run the debug in another router as well. Here also will come as a same problem. Yeah. See here, 1.1. Active open failed. Okay, update source is null, not available. Now let me undebug debug all. We should not use this debug command and all in live production until unless it's required. Okay, it will consume more CPU. It will make a outage. So this is a lab environment. I want to show you guys. Okay, how to see this packet. Okay, because of that, it was having a problem. Now router BGP 2. Sorry, I'm on router 1, neighbor IP. What is that? 2.2.2.2, update source as, we can give IP also. Okay, I'm giving here loopback 1. Now similar, I need to configure here router BGP 2, neighbor 1.1.1.1, update sources load back. So, oh, let us see. String 2.2.2.2 sources loopback 1. Okay, here another problem is a picture. By default, eBGP will work with the TTL1. You see here, by default, if you see this packet under, see here, TTL1. Okay, here it is assuming that, okay, by default TTL is 1 in the eBGP. Okay, we have to manually configure as a that TTL value. Okay, see this is my loopback is one hop away from my router. So we need to configure TTL value. Multi hop. That's what multi hop. Router BGP to neighbor to 1.1.1.1 multi eBGP multi hop. I am putting a 2 hop away. The same I need to configure in router one also neighbor 2.2.2 eBGP multi hop. So then only this neighborship will get formed. Now see here, as soon as we have configured, it has formed. See here, we could able to see all open, SYNAC, all those messages. If you open this message, let me open this first SYNAC message. So you see here, the TTL values are 2. This router reachability, okay, it is a, I have whatever TTL I have configured 2. Okay, if it is more than 2, it will not get established. By default, okay, if you see the older packets, let me show the older packets also. You see the older packets, my TTL value is a 1. Now I have configured a TTL value as 2. So it will be established the neighbor eBGP neighborship till 2 hop away. See, let me configure now. Let me show you few more things. Router BGP. I'm giving a 10 multi hop. Here also, let me give it 10. Multi hop 10. Okay. Now neighbor shut down. I'll shut down and turn it on. Now let us see. Now BGP will establish again. Let us see. Wait for a few minutes. Few seconds will take. It is already established, I guess. Let me open a SYN packet here. Let me. Let us set that the interface GI 0/0 shut no shut. Or the BGP. Okay. So it not went down. This is what a slow convergence in protocol. Okay. Within a fraction of a second, it went down and came up. Okay. It has not taken that. So we'll make it some more time. That's what a BGP has a slowest routing protocol. Sorry, I have to shut. Okay, my bad. Okay, no shut. We'll wait for a few seconds. Okay, I want this BGP also should go down. Sorry, I'm waiting. After that, we'll see in the new BGP message. Okay, the TTL will we can see as a see to avoid this. Okay, we can configure as a BFD. Okay, BFD if you configure, okay, as soon as the peer is not reachable, it will go down based on the time frequency we configure. That and all we will discuss in upcoming session. Okay, otherwise, if service provider link also get interface also flaps also, the BGP will never go down. Okay, if every 1 second is getting flapped, then BGP will never go down. Okay, we'll see BGP is up, BGP is up. Okay, but still my traffic is not flowing. Okay, we have a slowness, we have disconnection, all those things we'll discuss. So always BFT should be configured. Okay, when BGP is there. It will take 3 minutes. Okay. Why? Because 180 seconds BGP timer. Let us wait for few more minutes. BGP conversion is 180 seconds. Will BGP is yes. See, it has taken a one third 180 seconds. Now let me turn on my interface. Oh shit. Now let us see the capture here. A BGP will get formed newly. Let us see this graphic. Immediately it came up. See here, these are the BGP traffic. Okay, we could able to see BGP traffic. Let's see. You open here. See here, time to leave 10. Earlier, which we see as a 2. Now, after we are updated, okay, the time to leave, okay, it can form the BGP, eBGP neighbor till next 10 hops. Okay, if it's a more than 10 hops, it will get fail again. That is the purpose of eBGP multi-hop command, where router is away from. By default, eBGP will have a TTL value as a 1. Okay, if that neighbor router is far away, how many hops? Okay, based on that, we have to configure a multi-hop. Okay, till 255 multi-hops it supports. Let me show you that as well. config router BGP to neighbor 1.1.1.1. See if we give so eBGP multi-hop. It will supports up to 255. Okay, that's what I want to show you. Now let me show the configuration. This is the configuration which we configured for today's. Okay. First, I have configured back to back with the IPs, and then now we have configured with loopback. Overrun section BGP. The second configuration I have done with the loopback to loopback. This is the configuration. Please try out the lab and do lab